You can go on eBay, buy a $10 telescope and point it towards Jupiter, and you will see the exact same thing that Galileo saw. Hello beautiful, wonderful, fantastic people. I hope you're all having a wonderful day. My name is Petr Lebedev, and today I'm going to tell you a little bit about planetary science. Welcome to Cafe Classroom. So the thing I want to talk to you about today are the three things that have really made planetary science what it is today, and why this is the best time ever in all of history to be into space and science and astronomy. The first one is relatively simple. It's just a simple device that is a tube and two lenses. You put two lenses into a tube and you can figure out the wonders of the night sky. Before the 16th century, all of the astronomy that humans did was just done with the naked eye. And you can see a lot of really interesting things with just the naked eye. But the telescope was the next step. And what's really interesting is, just by looking up, you can see that there's all these stars. And these stars seem to stay very stationary. They don't seem to move around too much. And there's these other stars that wander from day to day. And we call those stars planets, because that's the Greek word for wanderer. And we can trace their patterns throughout the night sky. But to do the next thing, we had to wait until Galileo, who took the telescope, which was used in warfare to spy on the other team, and he pointed it upwards. And when he pointed it upwards, he saw a bunch of really incredible things. Such as that Jupiter has a bunch of moons orbiting around it, right? And you can see this with a really cheap telescope today. You can go on eBay, buy a $10 telescope and point it towards Jupiter, and you will see the exact same thing that Galileo saw. And the other thing that humans were able to see for the first time with the telescope was the Rings of Saturn. Believe it or not, before the invention of the telescope, we didn't know that Saturn had rings, which I think is just fantastic, right? And now with bigger and better telescopes, we can basically peer back right in towards the beginning of time, right towards the afterglow of the universe, right? Afterglow of the Big Bang. And in my opinion, the second really big stage, the second big progress, was the invention of rockets, right? And there's not much to be said here. Rockets are really cool, right? We can put people into a rocket and send them to the moon, right? We live in a world where 12 people have walked on the moon, and they worked on the moon, and they slept on the moon. And the amount of science that got done from the Apollo missions is just absolutely incredible. We found out so much more about our celestial neighbor by bringing back a bunch of moon rock and doing a bunch of geological sampling and learning more about not just the moon's history, but the Earth's history, right? We weren't able to do any of this less than 100 years ago, right? And we take this for granted. Right? Rocket launches are a relatively pedestrian thing nowadays. They're so incredibly common, and again, we couldn't do this less than 100 years ago. And the third thing that is really exciting to me is the space robots, right? Our robotic messengers that we send out into deep space because it's too dangerous to send humans. Right? But we basically littered Mars with wonderful, wonderful rovers. Rest in peace, Opportunity. And all of these rovers have done so much incredible science, right? Recently we found out from the Curiosity rover that there is seasonal variation in the methane levels on Mars, which leads to two really interesting conclusions, right? One is that there's some kind of biological life there right now, which is relatively unlikely, but we can't fully dismiss that. And two, that there is some kind of geological process that is happening that is releasing this methane. And we know exactly what that process is, because we get that on Earth, right? So when you take a bunch of hot water and you run this hot water by olivine, right? It's a very beautiful green mineral. That creates a mineral called serpentine and a bunch of methane. So what's really interesting about this, discovery of atmospheric methane and the seasonal variations in this atmospheric methane, is that either Mars is alive biologically or alive geologically. And it's most likely the second one. What's also really interesting is this paper came out a week ago in from the AGU, the American Geophysical Union, where there is now a theory that says that Mars is still volcanically active. So there's a satellite that had a bunch of radar data, and it found a lake of liquid water near Mars' south pole, right? And Mars is an incredibly cold place, right? And the south pole of Mars is an even colder place. And the temperature conditions are just not right for liquid water to be there without some kind of extra source of heating. And obviously this is still incredibly contentious. This paper just came out and we'll need to go for more stages of testing and more scientists will need to agree on this. But it seems maybe promising that there's some kind of volcanic activity still happening on Mars, which we didn't know about until last month, right? So what I'm trying to say is right now is the best time to be into space. It's the best time to be into science. Get into science, right? And I think some absolutely incredible things happen when you can kind of combine the telescope, the rocket, and the robot, right? Basically all of our advances in planetary science and astronomy have come from a combination of those three things, right? Something like New Horizons, which we launched in 2006, which reached Pluto in 2015, right? And was able to study Pluto in amazing detail for the first time ever. And it just flew by a Kuiper Belt object called Ultima Thule, which was really interesting because when you take a photo from one angle and the picture comes out looking like this, we as scientists tend to assume that these two things would be spheres. Physics really likes spheres, right? Like when you take a little bit of water, sorry, I'm gonna clean up later. When you take a little bit of water and you drop it, right? The surface tension naturally pulls the water together into spheres, right? And gravity also does that. For large enough planets, you get, that's why all the planets are round, including Earth. I'm looking at you, flat earthers. So physicists just tend to assume that things are spherical because it also makes calculations a lot easier. But when New Horizons flew past Ultima Thule, which is, this is 19 kilometers across, right? This is a very small object, but still larger than Sydney CBD, right? When it flew past it and looked at, took a picture from another angle, it's really actually interesting that instead of it looking like a snowman, it really looked like two pancakes stuck together. And we don't know why. We currently don't know why. All of the planetary scientists I know are currently scratching their heads. We don't really have a good theory that explains this kind of formation of Kuiper Belt objects. And again, we didn't know this until literally last month, right? This is the best time to be into space and into science. I'm gonna keep repeating that, right? And we're able to put just amazing, beautiful telescopes into orbit, right? And that really gives us very clear images because the atmosphere doesn't get in the way. So pictures from Hubble, right? And I'm incredibly excited for the James Webb Space Telescope that we're hopefully launching next year. They were meant to launch it in 2016 and 2014. There's all these delays. But there's a good reason for that, is because we're taking this telescope that is 6 meters in diameter, that is plated with gold, and putting onto a relatively small rocket. So we actually had to use origami techniques, origami folding techniques, on this gold leaf space telescope. And we're putting it on a rocket, and we're putting it into Lagrange point 2, which is kind of where all the gravitational pulls from the Earth and the Sun and the Moon, and ideally the other planets, cancel each other out. So you can put something there and it shouldn't drift away from that orbit. So we're putting a telescope there. And getting there is really kind of tricky, and if there's any mistakes, it's going to be really hard and really expensive to fix, so we're making sure that we get this right. But the James Webb Space Telescope is going to have a much greater resolution than Hubble, and it is much more sensitive to infrared, which means we'll be able to see galaxies that are just tens of billions of years old. 10 billion, 12 billion years old, right? And that is just an absolute dream for astronomers. And again, we just didn't have the knowledge, we just didn't have the technology before, the 21st century. So if you're not into planetary science, if you're not into astronomy right now, jump on board. It's really fun.
Hi, I'm Ravi Prasad from Parliament on King. Aside from the cafe, we also have a social enterprise catering business. We work exclusively with members of the asylum seeker and refugee community. We make food from their homeland the way they make it at home. If you'd like to support the work we do with the asylum seeker and refugee community, just click the link below, which you see in the comments. Thanks for supporting the work we do.